9.4, distribution of monomials. Learning objective, I can distribute a monomial into a polynomial expression. Okay, so order of operations, GEMS or PEMDAS, tells us that grouping symbols should be dealt with first. So for example, given 5, parenthesis, 6 plus 8, close parenthesis, GEMS tells us to add first because it is within the parentheses. So after we've added 6 and 8, we would have 5 and then in parentheses 14. And then we would multiply to get our final answer of 70. However, when we have variables in our expression, that's not always possible. So using a similar example, given 5 parenthesis x plus 8, we would try to add first. We can't because x and 8 are not like terms. So now what? Are we just stuck? No. You guys should have learned this already, but we can use the distributive property to expand our expression. So we would multiply each term in the parentheses by the number just in front of the parentheses. Thus, we would get 5x plus 5 times 8, or 5x plus 40. We can also do this when the number outside the parentheses is a variable, too. So here's some examples for you on how we do this. So when we distribute, we have to take this number out here, and we have to distribute it into every term. So anytime you see a plus or minus sign, that tells you when you can split, okay? So this is 1, and then we see this plus sign here, so that tells us we have to do another one. If there were another plus here, then we would have to go again, okay? So this was once described to me like the mailman, okay? So 8 is the mailman. Now, the mailman has to go to every house. He can't just skip over some of the houses because he feels like it. He has to go to every house. So 8 times y would be 8y. 8 times a positive 2xz would be plus a 16xz. Now, if you can, you should combine like terms here. In this one has a y, this one has an xz. So these are not like terms, and we have to just leave it just like that. But we go ahead and box that and say, okay, we've distributed that. We've expanded that. Okay. So here's another example. I told you guys that you could do it with a variable too, and that's true. So if we have x, we got to take it to the first one. Okay. And then I see a plus sign, so that means I need to do it again to the second one. Now, x times x, we could write it like this, or we could write x squared. Plus x times 1 is x. Now, remember, to be like terms, they have to have the same variable and the same power. So because one of them has a power and one does not, we're stuck here, and we leave it at x squared plus x. Okay. So there's 2 more here that I want you guys to go ahead and try on your own. In class, we're going to do this with our partner. So go ahead and try these and unpause the video when you're ready. Okay, hopefully you were able to do this without any help. So we would do 3x times y and 3x times 4z. So 3x times y gives us 3xy. Plus 3 times 4 gives us 12. And then 1x and 1z. Now again, we look and see if we can combine any of these. They do not have the same variable, so we are stuck. Okay, now this one. So this one, I don't know if you guys caught this or not, but this actually has a minus here. This 2x is not right up against these parentheses. Okay, so there's this invisible 1 hiding right here. So we take this negative 1, and that's what we distribute. Okay, so this 2x just hangs out here. It's not actually being distributed in. Then we would do negative 1 times 4x, which would give us negative 4x, and negative 1 times by positive 2, which gives us a minus 2. Now we look and see, do we have any like terms to combine? And on this one, the answer is actually yes. 2x and negative 4x are like terms. So 2x minus 4x gives us a negative 2x minus 2. Okay, and that would be our answer. Okay. All right, a couple more. So I actually want you guys to do this one on your own. So I will leave you to do that one. If you get stuck, let me know, but I think you can do it. And then I'll do example 6 for you guys. So again, this time we're going to have an x multiplying in. So that's fine. Okay. And this time it actually wants us to solve for x. It wants us to get a value for x. So the first thing we do is we do x times 2x. So that's 2x squared. Okay, x times x is x squared. There's this secret 1 there if you want to put it there, if that helps you remember. You do 1 times 2. And then we have a minus sign, so it's going to be negative. So 1x times 4 would give you 4x, and then it's divided by x, and that's supposed to equal 14. Now, this is the same as negative 4 times by 1. Because of that x over x. So we actually don't need that. We can just simplify this right here to negative 4, and it should equal 14. Okay, now our goal is to get x by itself, so we're going to add this 4 over to the other side, and we're going to get 2x squared equals 18. Still trying to get x alone, so we're going to go ahead and divide by 2, and we're going to have the x squared equals 9. Now if you remember how we undo the x squared, we do a square root to cancel the square. So we get that x equals plus or minus 3. Okay, remember, negative 3 times negative 3 would also give you 9. So we need to make sure we have the plus or minus there. And you can always double check these. So if we go back and plug these into the original equation. So I'm going to check 3. So we can take this 3 and plug it in anywhere we see an x. So we could do 3 on the outside here, times 2 times 3 minus 4 divided by 3 should equal 14. So we can either distribute or we can put it in our calculator. It doesn't really matter. I'm going to go ahead and distribute. So 3 times 2 times 3 would be 18. Okay? 2 times 3 is 6. 6 times 3 is 18. Minus, so now this 4 is being divided by a 3 and multiplied by a 3. Those are going to cancel. And you're going to be left with 4. 18 minus 4 is 14. 14 does equal 14, so that one's good. Now I want to show you what happens with a negative 3 also. So we'd have the negative 3 on the outside. 2 times the negative 3 there. Minus 4 divided by negative 3. Okay. It's not this one. Nope. Okay. So negative 3 times 2 times negative 3. So those negatives are going to cancel, and you're going to get a positive 18 again. And then we do negative 3 times a negative 4 divided by a negative 3. So that's a whole bunch of negatives. So let's go ahead and cancel these ones and just make those positive, because those two are going to make it positive. Now negative 3 times 4, a positive 4 divided by that, those are going to cancel, and we're left with a negative 4. So this one actually works also. So that's why we need both answers here. X could be positive or negative 3. Okay. All right. Last thing, the most important thing to remember about distribution is, you tell me, what's the most important thing to remember for you? Okay. If you want to see and check your answer for this one, it will be on the notes on Canvas. Let me know if you have any questions. Good luck on your 9.4 assignment.